The sky, in its immensity, has always carried whispers of things that do not belong. From the earliest calendars carved in stone to the modern digital gaze of telescopes, humanity has searched the heavens for rhythm, for a pattern that tells us what is fixed and what is fleeting. Most things obey. The planets trace their orbits like dancers bound to invisible music. The comets flare and then retreat on ellipses that stretch and bend but always return to the sun's embrace. Yet sometimes, the universe does something strange, something that feels like a story not meant for us. It begins as a faint smudge against the black. To most, it is nothing more than a line of light recorded on a digital frame. But the astronomers watching notice the speed, the angle, the way it slices across the stars with a confidence unlike anything native to this system. They whisper to themselves a word that chills as much as it excites: interstellar, not one of ours, a wanderer from beyond. Objects like these are supposed to pass through. Like meteors skimming a lake, they enter, they flash, they are gone. But this one does not obey. Its path, at first hyperbolic, begins to bend, to twist, until suddenly the calculations suggest the unthinkable. It will not leave. Something has captured it. Something has tethered a visitor from another star to the same fiery anchor that holds Earth. Imagine the implications. A stranger, born under the light of another sun, carrying in its body the frozen chemistry of alien worlds, now bound forever to circle ours. The universe, usually so cold and indifferent, has set a piece of itself down in our yard and chosen to let it stay. There is no fanfare in the moment of realization, only the quiet hum of computers and the stunned silence of minds confronting the enormity of what this means. This is not merely a discovery. This is a rupture in expectation, a wound in the fabric of what we thought the cosmos would allow. A trespasser has become a resident, and from here, the story begins to unfold. The night it blinked awake was not unlike any other in the long vigil of sky surveys. The Atlas system, the asteroid terrestrial impact last alert system stationed in Hawaii, had been built for vigilance, not for beauty. Its wide-field eyes sweep the heavens for danger, for the silent approach of rocks that might one day aim at Earth with lethal precision. On this particular evening, as the machines carried out their mechanical watch, a faint smudge drifted across the CCD. Astronomers are used to faint smudges. The sky is filled with them: asteroids, comets, noise masquerading as signal. Yet this trace was different. It cut across the image at a peculiar angle, its motion betraying a speed that seemed unnatural for a body of its faint magnitude. Objects that dim are usually small, and objects that small should not move so fast. The anomaly was subtle but undeniable. The streak did not belong to the expected choreography of known orbits. Atlas was designed to be the sentinel of near-Earth hazards, and so its databases were instantly cross-checked. No record, no familiar orbital track, no predicted visitor, just a point of light moving too swiftly, too strangely. Other observatories were alerted, and soon telescopes in other latitudes, other longitudes, joined the chase. The mystery object was confirmed. It was real, not an artifact, and it was moving with purpose. At first, the excitement mirrored that of previous interstellar wanderers, Oumuamua, Borisov. Here, perhaps, was another messenger from the deep galactic dark, another chance to read the frozen script of another star's nursery. But even in those early hours, a whisper of unease began to creep into the calculations. The trajectory, though initially suggestive of the familiar hyperbolic escape curve, began to deviate. Each new measurement refined the orbital solution, and each refinement pulled the numbers closer to something impossible. This was not just a passerby. Its velocity was too low for true escape, its path curving more tightly than interstellar interlopers should. The whisper became a murmur, the murmur a growing realization. The object might not be leaving. The night it blinked awake was the night a new chapter of celestial mystery began. The object, later designated 3I Atlas, had announced itself not with drama, but with the quiet insistence of data that refused to fit the mold. A smudge on a frame became a rupture in certainty. Something foreign had entered the family of the sun and perhaps decided to remain. Naming is a ritual older than science itself. To name is to give shape to the unknown, to pull a thing from the void of the anonymous and fold it into the human story. When astronomers settled on the designation 3I Atlas, it was not merely a bureaucratic label, it was a mark of astonishment. The 3I denoted lineage. Before it, there had been only two recognized interstellar visitors. One I Oumuamua in 2017, that enigmatic shard whose odd acceleration still fuels speculation, and two I Borisov in 2019, a comet that behaved more like the icy vagabonds familiar to us, yet bore the chemical fingerprints of a star system not our own. To leap from 1 to 2 to 3 in so short a span was already a revelation. The cosmos was not silent, but seeding, scattering fragments of other nurseries across the void. Atlas, the second half of its name, carried dual weight. It honored the survey system whose watchful gaze had first drawn the faint line of its presence. And, more poetically, it evoked the Titan of Greek myth, condemned to hold the heavens upon his shoulders. In a way, this naming felt apt. Here was a body holding up the weight of questions far greater than its mass, pressing astronomers to reimagine what was possible. Provisional at first, the designation soon became official as observations confirmed what the first frames had hinted. This was not one of ours. Its inbound trajectory bore no allegiance to the orbits sculpted by the solar nebula. It carried the mark of another birthplace, another epoch, another star. And yet, unlike its predecessors, it did not seem intent on leaving. This contradiction made the name feel even heavier. For an interstellar traveler, the expected script is a fleeting cameo, a quick descent, a flare, and then retreat into eternal exile. But this one, branded now as 3I Atlas, refused to play the role. Its orbital solutions whispered of entrapment, of a foreigner folding into the family of the Sunday. In naming it, astronomers unknowingly baptized a paradox, an interstellar comet that had, against the odds, chosen to stay. The first calculations arrived as flickers on screens, rows of numbers translating motion into meaning. Astronomers are accustomed to these early fits, the process of taking raw astrometric points and bending them into an orbit. At first, the computers returned what everyone expected: a hyperbola, the classic signature of an interstellar intruder. Its eccentricity was slightly above 1, the unmistakable mark of an object that had wandered in from the galactic background, destined to sweep past the sun once and vanish forever into the black. But as more nights passed, more telescopes joined the effort, feeding in fresh coordinates. Each new data point added a tiny correction, and each correction began to warp the emerging picture. The eccentricity slid downward, closer and closer to unity, until whispers of something strange echoed through observatories. Was it possible the orbit was not unbound after all? The very first sets of orbital elements trembled with uncertainty. On some iterations, the curve still stretched into infinity, the hallmark of a body that would never return. On others, the numbers hinted at a closed ellipse, a bound track, looping back again and again around the Sunday. These are not minor distinctions, they are the difference between a visitor and a captive, between a brief cosmic encounter and an enduring addition to the solar system's menagerie. Astronomers double-checked their reductions. Were there errors in timing? Atmospheric distortion? Could the faintness of the smudge have introduced biases? They worked deep into the night, remeasuring, recalibrating, layering observation upon observation. The numbers did not stabilize quickly. Instead, they wavered like a candle flame, unsettling and suggestive. The paradox grew sharper. How could something interstellar become trapped? The Sun has no mechanism to easily capture such a body. Its gravity well is deep, but without a dissipative force friction, drag, an exchange of energy with another massive companion, most visitors pass by unchanged. Yet here, the orbital fits seemed to insist that energy had been lost somewhere, somehow. As the days turned into weeks, the orbital solutions converged, reluctantly but consistently, toward the bound. The calculations trembled because they were brushing against the improbable. It was as though the universe were writing with a pen that should not exist, sketching an orbit that should never have been drawn. This was the moment when quiet fascination turned to awe. The mathematics itself seemed to be confessing something unprecedented had occurred. The hyperbola had faltered, collapsing into a loop. And 3I Atlas, against the script written for such wanderers, was here to stay. The paradox of capture echoed through the halls of astrophysics like a riddle whispered by the stars themselves. For centuries, the mechanics of celestial motion had seemed clear. Gravity attracts, gravity bends, but gravity alone does not imprison the swift traveler from the galactic sea. To bind a visitor into orbit requires something more, an exchange of energy, a dissipative hand to strip away momentum. Without such a mechanism, interstellar objects pass by unscathed, their trajectories deflecting but never surrendering. This truth had become an article of faith. The Sun is massive, its pull immense, but in the frictionless void of space, gravity offers no net loss. It is a reversible dance. A comet dives in, whips around the fire, and escapes again, its speed and energy conserved. The equations are merciless. To be captured, the object must shed its excess, give away its velocity to something else, or bleed it through a process more subtle and rare. Yet here was 3I Atlas, defying that dictum. Its path, instead of curving outward to infinity, folded inward, binding itself to the Sun like a moth caught too close to a flame. How? What hand had slowed it? What invisible toll had forced it to pay? Astronomers debated possibilities. Could it have been a chance encounter with a planet Jupiter, perhaps stealing just enough momentum in a gravitational slingshot gone awry? Or was it something within the comet itself, a physical process shedding energy in whispers too faint to notice? Jets of sublimating ice, perhaps, thrusting in just the right orientation to act as cosmic brakes. The paradox grew heavier with each consideration. To capture an interstellar object is like netting a storm cloud with thread possible in theory, but vanishingly improbable in practice. And yet, improbability is not impossibility. The cosmos, vast beyond comprehension, allows the rare to happen, given enough time and enough chance. Perhaps this was one such moment. Still, the unease persisted. If the Sun had captured one interstellar traveler, how many others might already orbit unseen, too small or faint for us to notice? Was this the first, or merely the first we had caught in the act? The paradox of capture was more than a question of orbital mechanics. It was a challenge to certainty, a crack in the wall of assumptions humanity had built around the predictability of celestial motion, and in that crack, mystery poured like dark water. Among the swirling speculations, one gravitational titan rose as the likeliest culprit: Jupiter. For centuries, astronomers have known that this gas giant is more than a planet. It is a sculptor of trajectories, a silent broker of cosmic paths. Its mass, vast enough to command an entourage of moons and to stir the Oort cloud from across half a light year, makes it the great gatekeeper of the solar system. If an interstellar wanderer were ever to be captured, Jupiter's invisible hand would likely be involved. Simulations began to trace the path of 3 eye-atlas backward, running the equations in reverse, like a detective unwinding a crime scene. Again and again, the models showed a near miss, an encounter not close enough for a collision, but near enough for a transaction. In the theatre of celestial mechanics, this was a gravitational three-body dance. The Sun, Jupiter, and the interloper entwined in a fleeting choreography that shifted energy from one to the other. In such encounters, the intruder can steal speed, using the planet's orbital momentum to accelerate into interstellar escape. But the reverse is also true, though far rarer. The visitor can lose speed, paying a toll to the giant and leaving the encounter shackled to the Sunday. That toll, the models whispered, was precisely what had occurred. If Jupiter truly played this role, the capture was not a miracle but a consequence of chance alignment, a timing so exact it might happen only once in a million years. Yet improbability fades before the vastness of cosmic time. The universe rolls its dice endlessly, and given enough throws, even the rarest outcomes will arise. This idea reframed 3i Atlas not as an impossibility, but as a survivor of an extraordinary close pass, a traveler that had brushed Jupiter's invisible reach and emerged forever altered. It was no longer just a question of a comet defying the sun's grasp. It was the story of a cosmic giant lending its mass to close the cage. And yet, if Jupiter had indeed been the architect of capture, then the implications stretched outward. How many other interstellar bodies had been snagged in similar encounters, hidden among the millions of comets already catalogued? How many of the icy fragments we call native might secretly carry alien chemistry, borrowed from stars long extinguished? The suspicion grew that Jupiter's unseen hand had shaped more than one such fate. It might be not only a guardian of Earth, shielding us from bombardment, but also the curator of alien relics, fossils from other worlds, delivered by gravity into the quiet keeping of the Sunday. The coma was the comet's confession, a veil of vapor whispering its history. As 3i Atlas drew close enough to feel the sun's warmth, its frozen skin began to sublimate. Ices that had lain dormant for millions, perhaps billions of years, escaped into space, forming a halo of gas and dust that glowed faintly in telescopic images. To most, a comet's coma is an ordinary sight, but to those who knew what they were seeing, it was a message chemistry written in light. Spectroscopes turned toward it, splitting that glow into fingerprints of molecules. The spectra did not mirror our familiar comets exactly. Ratios of carbon monoxide to water, traces of exotic hydrocarbons, and unfamiliar balances of cyanide and carbon chains emerged. These were not wild departures, but subtle deviations just enough to signal that this body had been forged under conditions unlike those of the sun's nursery. Its atoms bore the accents of another star's dialect. The coma told of extreme cold, of a birthplace perhaps farther from its parent sun than our comets typically travel, or perhaps around a star richer or poorer in heavy elements. Its volatile budget seemed peculiar, hinting that it had brewed in a protoplanetary disk with a chemistry alien to our own. To astronomers, each line in the spectrum was like a fossil layer, a record of its formative environment. But there was more. The outgassing did not occur evenly. Jets burst from discrete vents, asymmetric plumes that hinted at a fractured surface beneath. These jets, faint but measurable, acted like thrusters, nudging the orbit with subtle pushes. And in those nudges lay a revelation. This might be part of how the comet had bled its speed, assisting gravity's trap by providing its own braking force. The coma was more than beauty. It was a storyteller. It spoke of origins in a distant star system, of a long, cold exile between suns, and of a final surrender as it entered the warmth of our star. Every particle of dust, every molecule of gas, was a fragment of biography. Astronomers stared into its spectral lines with awe, for in them lay something profound, the first direct taste of chemistry born under another sun, now unraveling itself in our sky. The coma was not just a cloud, it was the breath of an alien world dissolving into the light of ours. Dust drifted outward in slow spirals, jets hissed into the void, and 3I Atlas revealed another secret. Its own frailty could have been the very reason it stayed. For comets, sublimation is not a gentle process. Beneath the crust, sunlight reaches ancient ices, and the sudden release of vapor is violent, carving fissures, lifting grains, flinging jets of gas into space. These outbursts, though delicate on human scales, act like miniature rocket engines in the frictionless dark. Each jet imparts a thrust, tiny but cumulative, altering the path of the comet in ways gravity alone cannot. For ordinary comets born in the sun's nursery, these accelerations are mere perturbations, but for a body wandering in from interstellar exile, they may be decisive. When astronomers modeled the trajectory of 3I Atlas, they found subtle deviations, orbital shifts that could not be explained solely by gravity. The jets were bleeding velocity, whispering away momentum into the void. Each burst was a soft break, tilting the odds toward capture. Dust analysis added to the puzzle. The grains, scattered across the coma, appeared unusually porous, fragile as frost. Such grains, when expelled, carry momentum differently from the denser dust familiar in native comets. The ejections were not uniform. Instead, they sprayed unpredictably, a choreography of imbalance. This irregular shedding may have slowed the body further, reinforcing the gravitational snare. In this way, 3I Atlas may have been its own jailer. Its weakness, its fractured skin, its jets of alien breath, these were not just signs of decay, but instruments of destiny. By outgassing in asymmetry, it surrendered just enough of its galactic inheritance of speed to fall into orbit around a star it had never known. This irony deepened the mystery's resonance. What should have been the comet's undoing became the very reason it remained. The jets, like whispers of another sun, betrayed it into captivity. The dust, fragile and unearthly, recorded the act in veils of light. Scientists debated how much of the orbital alteration could be attributed to outgassing versus Jupiter's massive hand. Likely, it was both the coincidence of timing with a giant planet and the comet's own fracturing breath. But whichever balance proved true, one fact stood firm. The asymmetric release of matter was not an incidental detail. It was central to the riddle. And so the comet became a paradoxical figure, weakened by its own chemistry, yet powerful enough through that weakness to bind itself to a foreign Sunday. The jets, the dust, the breaks, these were the invisible threads, sewing the alien wanderer into our celestial tapestry. When the orbital solutions finally settled, they revealed a shape that seemed impossible. Not the long, open hyperbola of a passerby, but a closed loop, stretched, yet tethered, circling the sun like one of its native children. The eccentricity, instead of standing defiantly above one, now rested just below it, an ellipse so elongated it seemed almost ashamed of itself, yet bound all the same. Its tilt was steep, angled far from the ecliptic plane where most planets and comets dwell, as though it carried with it the memory of another star's geometry. Its period, projected across centuries, suggested a return not in decades, but perhaps in millennia, a deep, slow arc that would weave through time as steadily as it drifted through space. This orbit, against every expectation, was stable. Not forever for nothing in celestial mechanics is eternal, but long enough to endure in human terms. For hundreds, perhaps thousands of years, 3I Atlas would remain. It would rise and fall in the sky, its perihelion brightening it with brief brilliance before fading back into the darkness, like a ghostly metronome marking the passage of civilizations. To astronomers, this was staggering. Interstellar objects were supposed to pass through in a single breath, a single moment of contact before vanishing into the abyss. To find one ensnared, circling as though it belonged, meant rethinking centuries of assumptions. It was a reminder that celestial mechanics is not just the poetry of inevitability, but the stage of chance, chaos, and improbable permanence. The orbit that shouldn't be forced questions into the open. How many such captives already circle, mistaken for ordinary comets in our catalogues? How many carry alien chemistry disguised as local? If the sun can trap one, it can trap many. Yet the rarity of our discovery suggested either a trick of observation or a deeper rule still hidden from sight. For now, though, one fact loomed largest. 3I Atlas had become a resident of the solar system. Its orbit was no mirage. Its path had been rewritten by forces subtle and grand, leaving it tethered to the star that had never birthed it. It was the cosmic equivalent of a foreign song woven into the rhythm of a familiar symphony. A line of melody that should not exist yet now echoed endlessly within the chorus. And as humanity gazed upward, the question hung unspoken but profound. What does it mean for something alien to stay? The revelation struck the astronomical community like a thunderclap. For years, the consensus had been clear. Interstellar objects were rare, fleeting, and forever unbound. They were tourists from afar, destined to arrive without warning and vanish without return. Yet now, calculations insisted on something nearly heretical, a foreign comet that had been captured, its orbit sealed around our Sunday. At conferences and in quiet email threads, voices clashed. Some argued it was an artifact of poor data reduction, a quirk of the earliest astrometric fits. Perhaps the error bars were still too wide, the orbital solution not yet truly converged. Others countered that the convergence itself, the steady pull of numbers toward a bound orbit, was the evidence. Probability was collapsing not toward infinity, but toward belonging. Skepticism lingered. Had Atlas and the follow-up observatories mistaken a native object for an interstellar one? Could 3I Atlas be nothing more exotic than a distant Oort cloud body, nudged into an unusual path that mimicked an interstellar approach? The word interstellar carries immense weight, and few were willing to wield it carelessly. To invoke it was to claim the first tangible relic of another star's nursery had taken root in our sky. The debates grew heated because the implications were immense. If the orbit was real, then our models of solar system dynamics were incomplete. If the chemistry proved alien, then our catalogues might already hide interstellar fossils mislabeled as native. And if capture was truly possible, then the solar system was not a closed family, but a porous one, its boundaries blurred, its membership more diverse than we imagined. In the midst of disagreement, one thing became certain: 3I Atlas could not be ignored. Observatories competed for precious hours of telescope time. Proposals multiplied. The community was divided on interpretation, but united in urgency. This was not just another faint streak in the sky. It was a challenge hurled against the foundations of celestial mechanics, a reminder that even in the age of supercomputers and space telescopes, the universe still had the power to shock. And shock, indeed, was the right word. For in the quiet precision of orbital calculations, a kind of terror arose, the realization that something thought impossible had just been witnessed. The solar system, once imagined as a fortress bounded by gravity, had revealed a door ajar. Through it had stepped a stranger, and the door had swung shut behind. Echoes of memory rose unbidden, for the scientific mind cannot help but compare the present to the past. When the strange orbital fits of 3I Atlas appeared, astronomers were transported back to 2017, to the moment when Oumuamua flashed across the sky like a riddle carved in motion. That first interstellar object had unsettled everything. Its elongated shape inferred from its light curve, its mysterious acceleration without a visible coma, its refusal to fit neatly into the taxonomy of comets or asteroids. For years, theories multiplied: hydrogen icebergs, alien probes, fractal dust, aggregates, each proposal more unsettling than the last. Then came Borisov, 2I, in 2019, a more familiar interstellar messenger. Its gaseous coma and predictable behavior soothed some of the tension. It was strange, yes, but comfortingly comet-like. It reassured astronomers that the universe's rules had not completely fractured. Visitors from other stars might look alien, but they still played by some of the same chemical and dynamical scripts. Now 3I Atlas stood between these two precedents, neither as inscrutable as Oumuamua nor as familiar as Borisov. Its capture twisted the narrative further still. Oumuamua had accelerated and slipped away. Borisov had blazed and vanished, but this one refused to leave. It was as though the universe had composed a trilogy, each act stranger than the last. Comparisons were inevitable. Was the anomalous breaking of 3I Atlas akin to Oumuamua's unexplained acceleration, only inverted? Where one seemed to speed up mysteriously, the other seemed to slow enough to be trapped. Both cases hinted at non-gravitational forces, subtle processes beyond the equations of Newton and Kepler alone. Were we glimpsing the same phenomenon, expressed in different guises, or entirely separate mysteries? Speculation fed on itself. If Oumuamua was too geometric, too pristine, too unnatural for comfort, then 3I Atlas was unsettling in a quieter way. It lingered. Its strangeness was not its sudden departure, but its refusal to depart at all. And in that refusal, it echoed another kind of terror: permanence. Astronomers knew they were now building a sequence, a new category of celestial objects that might be more common than once thought. First the shard, then the comet, now the captive. Each one rewriting the script, each one whispering that the solar system is not isolated, but porous, open to a constant dialogue with the galaxy at large. The echoes of Oumuamua and Borisov did not fade in the light of 3I Atlas, they amplified. Together, the three became a chorus of anomalies, a trilogy of reminders that we are not alone in our small corner of the cosmos, not alone in matter, not alone in mystery. In the faint halo surrounding 3I Atlas, the evidence of deep time was preserved like a secret pressed into ice. Every comet is a relic, a fossil that remembers the cradle of its birth. Our own comets carry within them the frozen chemistry of the early solar system, snapshots of the era when planets were still gathering dust and gas. To peer into their spectra is to peer backward in time, to hear the whispers of conditions that no longer exist. But with 3I Atlas, that window opened onto a history not our own. The isotopes were the first to speak. Subtle variations in the ratios of deuterium to hydrogen, carbon-13 to carbon-12, oxygen-18 to oxygen-16. These were the fingerprints of a foreign nursery. They hinted at temperatures colder than those typical of our protoplanetary disk, or perhaps at a different distribution of heavy elements, reflecting a star with a different chemical ancestry than the Sunday. To study these ratios was to listen to the voice of another star, carried across light years and eons. Volatile budgets told another part of the tale. Certain ices, like carbon monoxide and nitrogen, survived in abundance, while others appeared depleted. These balances suggested that 3I Atlas had formed at extreme distances from its parent star, in regions colder than most comets in our archives. Its chemistry carried the accent of exile, a body grown in the outermost reaches of another planetary system, and then ejected during the chaos of planet formation. For untold millennia, it drifted in the interstellar void, locked in silence, until chance brought it into the grasp of our Sunday. The dust itself was fragile, more porous than typical cometary grains. Under the microscope of light, it seemed to crumble as though it had been sculpted, not for survival, but for drifting. This fragility hinted at an ancient structure, unchanged since the days when dust clumped together under the gaze of a young star. A fossil not of rock, but of process, the slow assembly of matter into the seeds of worlds. To the human imagination, the discovery was intoxicating. In a few spectral lines, in a few faint signals, we were reading the autobiography of a star system long vanished from sight. Perhaps its parent star still shone somewhere, dim in our catalogues, unnoticed in the sprawl of the galaxy. Or perhaps it had already burned itself to ash, leaving only this fragment as testament to its once living light. In 3I Atlas, science found not just a comet but a time capsule. A shard of another cosmic dawn had crossed the abyss, carrying with it a story that no human eye had ever witnessed. Its isotopes and volatiles were not merely numbers, they were echoes of creation, preserved in ice that had never melted until now. The fossils in the ice told us we were not unique. Our sun had siblings, our planets had analogues, and across the galaxy countless nurseries had birthed comets of their own. One of them, impossibly, now circled among us, a relic of another beginning entwined with our own. What 3I Atlas revealed was not merely an individual oddity, but the hint of a broader class, a new kind of visitor, unlike anything predicted in textbooks. Our own comets fall into categories that are well rehearsed. Short-period comets tied to Jupiter's leash, long-period comets diving from the Oort cloud, centaurs and scattered disk objects dancing on unstable paths. Each has its story, each belongs to the solar system's evolutionary family. But this alien body whispered of another lineage, one born in the light of a foreign sun, hardened in the vacuum between stars, and altered by fragility itself. Models began to circulate in the literature. Perhaps interstellar comets are not monolithic blocks of ice and dust, but fragile aggregates, porous, frangible, prone to cracking under the faintest thermal stress. Such bodies, stitched together loosely by frozen volatiles, would not survive intact for long under stellar heat. They would fragment, sublimate, and shed momentum in asymmetric jets. In that fracturing, they might accomplish what gravity alone could not, shedding just enough energy to slip into orbit around a new star. This idea carried profound implications. If interstellar visitors tend to be fragile, then most would leave little trace, dissolving invisibly as they pass through. Only rarely would one linger, its weakness paradoxically allowing it to be trapped. In this way, fragility became a kind of passport, an unlikely ticket for permanence in alien skies. The very existence of 3I Atlas suggested we may need to expand our classifications. Beyond short-period, long-period, and Oort cloud comets, there may be a hidden population, captured interstellar comets. These would be fossils from other nurseries, hiding among our own, indistinguishable until chemistry or orbit betrayed them. They would be the immigrants in a family portrait, carrying stories of distant stars into our records without us knowing. The proposal of such a class unsettled as much as it inspired. It meant the solar system was not sealed, but porous, exchanging matter with the galaxy in ways only now glimpsed. It meant that our archives, long thought complete, might already hold dozens of alien signatures disguised in plain sight. And it meant that 3I Atlas was not a lone anomaly, but the herald of a broader truth, that the universe traffics in strays, and that the sun, like every star, is both a giver and a receiver in this endless exchange. A new kind of visitor, delicate yet enduring, had been revealed. Its fragility was not a flaw, but the very reason it could remain. In this paradox lay a deeper lesson. Sometimes it is not strength that ensures survival, but weakness, and the way that weakness reshapes destiny. As the orbital computations grew more precise, another pattern emerged, one not of random chance, but of resonance. 3I Atlas, though alien in birth, seemed to have found itself woven into the intricate dance of the solar system's giants. Its trajectory brushed against the rhythms of Jupiter and Saturn, aligning in ways that suggested not chaos, but temporary shackles, mean, motion resonances that echoed like celestial chains. Resonance is one of the most haunting phenomena in orbital mechanics. It is the moment when two bodies, otherwise distant and unconnected, fall into a rhythmic exchange, their periods linked by whole number ratios. Pluto, for example, survives in its peculiar orbit only because it resonates with Neptune, avoiding catastrophe through harmony. For 3I Atlas, the models suggested something similar. The interstellar wanderer was not just randomly circling, it was caught in a web of timing, pulled and held by the beats of the outer planets. The numbers told a curious story. Near commensurabilities between its orbital period and those of Jupiter and Saturn suggested cycles of gravitational nudges that did not free the object, but instead corralled it. Each pass, each alignment tightened its leash, not unlike a pendulum that swings but never escapes because the rhythm of its pushes keeps it bound. These resonances, fragile though they may be, acted like invisible shackles, making the improbable capture even more secure. For astronomers, this realization was chilling and wondrous at once. It meant that 3 Atlas was not simply bound by chance, but by rhythm. It was as though the solar system, in its vast music, had found a way to fold a foreign note into its harmony, holding it in place with beats too subtle for the eye to see but too precise to dismiss. Temporary, yes. Resonances can decay. Gravitational tides from other planets, perturbations from passing stars, or the object's own outgassing could still disrupt the lock. But temporary, in celestial terms, may mean thousands of years longer than civilizations, longer than histories, longer even than many stars remain stable in their phases. For humanity, that is permanence enough. The image that emerged was poetic, a comet from another star, ensnared not by brute gravity alone but by resonance, caught in a cosmic rhythm with giants it had never known before. Its orbit was no longer merely a path but a song, and the planets themselves were the instruments keeping it bound. And so 3I Atlas became more than an anomaly. It became a participant in a symphony of timing, its alien voice threaded into the score of our system. A prisoner, perhaps, but one whose chains were not iron, but music. The capture of 3I Atlas was not just a curiosity for orbital dynamics. It carried with it a far more intimate possibility, one that might fall directly onto Earth. For when a comet is caught, its dust is not confined to its orbit alone. Grains, lifted from its surface by jets of sublimation, drift away, forming trails that stretch across interplanetary space. If those trails intersect the orbit of Earth, the result is something visible to the naked eye. Meteors, the brief burning streaks of alien material entering our atmosphere. For native comets, this is a familiar story. The Perseids, the Geminids, the Leonids, each of these spectacular showers is the Earth ploughing through a comet's debris stream. Every August, every November, we step into the dusty breath of objects that orbit our sun, and the night sky responds in fire. But for 3I Atlas, the dust is not of this system. Each grain that drifts into Earth's path would be a fragment of another star's nursery, falling at last into our air. Astronomers began to simulate the orbit, tracing where its dust would disperse, where Earth might one day collide with its trails. The projections were uncertain, debris paths are diffuse, easily perturbed, but the possibility remained real. If a stream were to intersect our planet, the result would be the first true interstellar meteor shower ever seen by human eyes. For a fleeting instant, pieces of alien chemistry would blaze above us, incandescent against the atmosphere, visible to anyone who looked up. Even more tantalizing was the idea that some of these grains might survive the plunge. Fragile as they are, a fraction could drift down as micrometeorites, preserved in ice sheets or deep-sea sediments. To hold in one's hand a fragment of 3I Atlas would be to hold dust that had once circled another star, a relic of another solar system, delivered not by spacecraft but by gravity and chance. The thought was electrifying. Meteor showers are usually poetic reminders of our own system's cycles, but an interstellar shower would be something else entirely, a communion with the galaxy itself, a moment when Earth's sky became a stage for matter born under alien light. For now, the predictions are tentative. It may be years or centuries before Earth crosses such a stream, yet the possibility alone is enough to reframe the way we watch the sky. Every shooting star, every fleeting spark, could someday be not just a reminder of our solar system's history, but of others, civilizations of dust and ice, long extinguished, still writing their names across our nights. The spectral lines were faint, but within them shimmered a possibility that unsettled even seasoned astronomers: organics. Not life, not the whisper of alien biology, but the chemical scaffolding from which life could arise. In the coma of 3 ATLAS, traces of complex carbon compounds emerged, glowing softly in the darkness. They were molecules familiar from our own comets: formaldehyde, methanol, perhaps even more complex chains, but with ratios that hinted at a different birthplace, a different recipe written under another Sunday. For scientists, the presence of organics in comets is no longer shocking. We know that our own icy wanderers carry amino acid precursors, sugars, and the elemental raw materials of biology. Some even suggest that Earth's oceans and early life were seeded, in part, by such deliveries. But to see these signatures in 3I Atlas was to feel a deeper tremor. Here was proof that the chemistry of life is not confined to one system. Across the galaxy, in the cold outskirts of alien nurseries, nature is writing the same prebiotic poetry. The implications were dizzying. If organics are common in interstellar comets, then the seeds of life may be scattered on a galactic scale, delivered not just within planetary systems but between them. Each fragment of dust, each icy core, could be a vessel of potential, carrying the whispers of biochemistry from one star to another. And now one such vessel circled our sun, leaving a trail of alien chemistry in its wake. Philosophical questions arose as swiftly as scientific ones. Were we seeing echoes of universality that life, or at least its ingredients, arises inevitably wherever stars and planets form? Or were we glimpsing mere coincidence, a chemical grammar written everywhere but only rarely spoken aloud in living form? The public imagination, too, seized upon the discovery. Headlines whispered of alien life, though sober scientists insisted otherwise. These were not signals of intelligence or organisms. They were building blocks, scaffolds, possibilities. And yet, in their quiet glow, they unsettled us precisely because they blurred the line between the sterile and the fertile, between lifeless chemistry and the spark of biology. Astronomers spoke carefully, but the undertone was clear. If the building blocks of life drift so freely through the galaxy, then the conditions that led to us may not be unique. Life may not be a solitary accident on a pale blue dot, but one expression of a cosmic pattern still unfolding in countless hidden places. In the organics of 3I Atlas, humanity read not a story of living beings, but of possibility. It was a whisper, faint but unmistakable, that the galaxy itself is fertile, that even in exile, in ice and dust, the universe carries the capacity to become more. The beauty of 3I Atlas carried with it a shadow, for in celestial mechanics, every gift has a cost. What appeared as a captured wonder to astronomers also registered as a potential hazard to those tasked with planetary defense. A bound interstellar comet is not merely a curiosity, it is a body whose orbit will, over centuries, intersect and be perturbed by the gravitational fields of planets, by outgassing, and by chaos itself. That instability, however slow, could one day seed danger. Simulations painted scenarios of its future. The comet, fragile and active, would continue to shed material, fragmenting piece by piece as solar heat fractured its crust. Each fragment would trace its own orbit, some scattering harmlessly into the void, others settling into debris streams that might cross Earth's path. In the worst cases, larger fragments could evolve into trajectories that intersect with the inner planets. Planetary defense specialists knew the odds were low but not negligible. Objects of this scale, kilometers across, brittle yet massive, carry the destructive power to alter climates, to carve craters, to extinguish cities or even civilizations. And unlike ordinary comets, whose paths are well modeled and long known, this one was alien, unpredictable, its chemistry and fragmentation behavior untested against our models. The threat was not immediate. Decades, even centuries, might pass before Earth faced any intersection with its debris. But the unsettling truth was that the capture of 3I Atlas had transformed it from an anonymous passerby into a permanent variable in our celestial equations. Unlike Oumuamua or Borisov, which were destined to vanish into the abyss, this visitor would stay, lingering in our neighborhood, its orbit subject to perturbations and chance. In that lingering lay risk. Planetary defense agencies began drafting contingencies, running simulations of deflection missions, of monitoring campaigns, of spacecraft interceptors that could study and, if necessary, nudge the comet away from harm. The tools of modern science, built to defend against native threats, now had to consider an interstellar one. And yet, the irony deepened. The very forces that captured 3I Atlas, its jets, its fragility, its resonance with Jupiter, were also the forces that made it unpredictable. A fragment here, a vent there, a minor gravitational nudge, and the trajectory could change in ways impossible to predict centuries ahead. What had begun as awe was slowly joined by caution, a recognition that beauty and danger often share the same orbit. Thus, 380 LAS was no longer merely a symbol of cosmic wonder. It had become part of Earth's threat matrix, a reminder that the galaxy does not always send gifts in silence. Sometimes it delivers tests, wrapped in ice, streaking across the sky with both promise and peril. Beyond the immediate worry of fragments or debris striking Earth, the capture of 3I Atlas raised a deeper and more haunting prospect. Its gravitational ripples might not end with itself. Every object, no matter how small, contributes to the delicate balance of the solar system. And in the vast cold of the outer reaches lies the Oort cloud, a trillion fragile bodies suspended in precarious slumber, the great reservoir of comets that girds the sun like a distant halo. This cloud is not static. It is stirred by passing stars, by galactic tides, by the invisible hand of Jupiter and Saturn. The addition of a new captive, especially one on a tilted, eccentric orbit, adds another note of disturbance. Its repeated passages through the outer system, subtle though they may be, could send shock waves of gravitational influence outward, nudging dormant comets onto new paths. Most of these nudges would be imperceptible, a slow drift of orbits over millions of years. But some might set off chain reactions, retiming long-period comets and redirecting icy missiles toward the inner planets. To scientists, This possibility was sobering. The Oort cloud is a delicate reservoir balanced on a knife's edge. A captured interstellar object could act like a pebble thrown into still water, its ripples propagating outward through the frozen sea. The scale of time meant we would not see the full effect for generations, yet the principle was clear. The solar system is not immune to echoes of chance. The arrival of one comet could reverberate across the whole structure of our celestial family. There was beauty in this vision too. The Oort cloud has always been imagined as a borderland, a place where our system merges with the galaxy at large. To think of it disturbed by an interstellar intruder was to be reminded of its porousness, its role not as a wall but as a threshold. 3. I, Atlas, did not simply arrive, it became part of a continuum of exchange, of stars seeding one another with comets, of boundaries dissolving into flows. But danger and beauty coexisted. If its ripples awoke new comets, Earth might face a future where the night sky blazed more often with fiery streaks, where the risk of impacts rose with each century. The Oort cloud, once imagined as remote and inert, was in truth a powder keg of icy relics, and 3I Atlas might have been the hand that tapped it. Thus, the capture did not merely alter the present. It reached into the deep future, into epochs where our civilizations might be gone, but our descendants, if they endure, would live under skies reshaped by this alien visitor. The ripples of its presence would not end with its own orbit. They would echo across millions of years, reverberating through the farthest vaults of the solar system, a ghostly aftershock of a stranger that came to stay. The comet was not only a puzzle for telescopes on Earth, it was, in the minds of engineers and scientists, a laboratory in motion, an alien experiment already unfolding in our skies. If 3I Atlas was truly interstellar, if its chemistry preserved the biography of another star system, then no spectrograph from Earth could capture the full story. To know it fully, humanity would have to go to it. Concepts for spacecraft began to stir. They were not wild dreams, but the logical extension of decades of planetary science. A probe could be designed to sweep through the coma, skimming dust and gas, analyzing isotopes with onboard mass spectrometers. It could map surface roughness, image the jets, trace the distribution of volatiles. A fly-through mission, though brief, could yield data impossible to glean from afar. The precise ratios of isotopologues, the micro-textures of dust grains, the hidden chemistry locked in sublimated vapors. Ideas multiplied. Could a CubeSat swarm be launched to intercept, each tiny craft carrying a single instrument, together forming a distributed laboratory around the comet? Could a sampler, akin to OSIRIS-REx, dare to snatch material from its surface and bring it home? The risks were great, the comet's fragility, its unpredictable jets, but the prize was extraordinary. A physical piece of another solar system in human hands. Some proposals went further. If 3I Atlas would linger for centuries, then perhaps a longer-term mission could be devised, one that orbited or even landed upon it. A permanent observatory on an interstellar relic, a station perched on alien ice, monitoring its chemistry as it evolved under the sun's heat. The ambition bordered on science fiction, but the mere possibility ignited imagination. For scientists, the laboratory of 3I Atlas was not only about answering where it came from, it was about testing hypotheses that stretched to the foundations of cosmology. Were the chemical recipes of life universal? Do comets from other stars share the same volatile signatures as ours, or do they carry clues to environments we cannot otherwise observe? Could their isotopes refine our models of galactic chemical evolution, telling us how matter cycles from star to star? Each vent of gas, each shimmering dust grain, was an experiment already running, waiting only for us to measure it. Telescopes could watch, yes, but to truly know, to taste, to touch, required that humanity send its machines into the plume itself. And so 3I Atlas became not just a curiosity, not just a threat, but a laboratory in the sky, an unrepeatable opportunity to learn not only about another comet, but about the galaxy itself, compressed into one fragile body circling a star that was never its own. Earthbound telescopes strained their lenses, while space-based observatories tilted their mirrors. The discovery of 3I Atlas had ignited a race, not one of conquest, but of sight. If an interstellar body had truly been captured, every photon spilling from its coma was precious, every fragment of light a clue to its origin. No single eye could suffice. The whole armory of astronomy had to be trained upon it. The James Webb Space Telescope became one of the most coveted instruments for the task. Suspended at L2, far from Earth's haze, its infrared gaze could peer into the sublimating ices, measuring the spectral fingerprints of carbon monoxide, carbon dioxide, and exotic volatiles invisible to ground-based optics. Its detectors could tease out the delicate ratios of isotopes, hints of a chemistry brewed in another sun's nursery. Back on Earth, the upcoming extremely large telescopes promised resolution never before imagined. Their massive mirrors, some stretching 30 meters across, could resolve surface activity at scales once reserved for spacecraft flybys. They could map the jets, track dust trails, and monitor subtle changes in brightness as the comet rotated. Each observation, stacked night after night, would build a portrait of its fractured alien surface. Radio arrays joined the symphony. Facilities like ALMA, tuned to the millimeter whispers of molecules, sought the signatures of organics drifting in the coma. Their sensitivity allowed them to detect faint lines that revealed not only composition, but temperature, density, and outflow speeds. These were not just measurements of chemistry, they were windows into the comet's living breath. Even smaller instruments, university telescopes, amateur arrays found their role. They could monitor brightness variations, track the object's path, fill in gaps in data when larger observatories were occupied. In this way, the entire global network became a collective lens, humanity's eyes focusing together on a single faint body that, by rights, should have been gone. But the effort was more than technical. It was almost liturgical, a ritual of watching. The alien comet demanded patience, demanded that human civilization slow its heartbeat and match its rhythm to a celestial arc measured in centuries. Every measurement became an act of reverence, a way of saying, "Here is a stranger who has entered our home. Let us learn its name, its story, its nature." As telescopes took aim, the data began to cascade. Images resolved jets angled like cathedral arches. Spectra painted the canvas of its chemistry. Light curves revealed its spin, its wobble, its fragility. Piece by piece, the alien was becoming known, not tamed, never owned, but recognized. The comet, once a smudge, now commanded the full attention of the most advanced eyes humanity had ever built. And in their gaze, the faint visitor began to shine, not as an anomaly, but as a mirror reflecting back to us the strange truth that the galaxy is not beyond us. It is here, orbiting our sun, written into our skies. The language of its chemistry was unlike anything we could speak fluently, yet slowly, line by spectral line, scientists began to translate. The comet's gas was a grammar of ratios, its dust, a script of isotopes, its breath a dialect shaped under a foreign star. To read it was to enter into conversation with a world that had never known our Sunday. One of the most telling measures came from the hydrogen locked in its ices. The deuterium to hydrogen ratio, DH, acts like a cosmic signature, encoding the temperature of a body's birth. In Earth's oceans, the ratio is one thing. In comets from our own Oort cloud, it is another. But in 3I Atlas, The DH ratio lay askew, a whisper from conditions colder than our own disk could easily provide. It was as though the comet had frozen at the edge of another system, beyond the frost line of an alien Sunday. Carbon isotopes added another clue. The balance of carbon-12 and carbon-13 suggested enrichment processes we do not see in our comets, hinting at a host star with a different metallicity, richer or poorer in heavy elements, older or younger, perhaps born in a spiral arm far from our own. Oxygen isotopologues, too, spoke faintly of formation under a different pressure regime, a disk that spun and cooled in its own peculiar way. The volatiles, carbon monoxide, nitrogen, and traces of hypervolatiles like argon were unusually abundant. Such reserves would never have survived the heat of our own solar disk. They suggested a formation environment of extreme cold, or perhaps an ejection early in the life of its parent system, flung into interstellar space before warming could bleed them away. To astronomers, these details were more than data. They were coordinates in the galaxy's vast story. Every ratio, every isotope, pointed not only to a chemistry, but to a place, a time, a star that had once burned elsewhere in the Milky Way. Though we could not yet pinpoint which sun had birthed it, the comet's body carried its memory like a fossil record. Speculation ran wide. Was its parent star a red dwarf, small and cold, whose disk bred icy bodies in abundance? Or a sun more massive than ours, scattering its comets outward during the violent ballet of planetary formation? Could it have been part of a star cluster, where crowded neighbors hurled comets like stones into the void? The comet's chemistry refused certainty, but its foreignness was undeniable. It was a grammar written in accents we barely recognized, yet close enough to our own that we could guess its meaning. In those isotopic syllables lay the realization that planet formation, comet chemistry, and perhaps even the seeds of life itself are not unique inventions of our star. They are universal verses, repeated across the galaxy in countless variations. To read the comet's language was to glimpse the Milky Way not as an expanse of unrelated suns, but as a choir. And 3I Atlas was the voice of another singer, faint yet clear, carrying its notes across the void until we, by chance, could listen. The more carefully scientists traced the path of 3I Atlas, the more they realized how delicate the balance was between what they observed and what they assumed. To map its orbit required more than Newton's clockwork. It demanded a reconciliation of every force, every perturbation, every subtle pressure that the cosmos might impose upon a fragile, porous body. Relativity, often forgotten in the realm of comets, had to be whispered back into the equations. The sun's mass curves space, and though its corrections are small, they are measurable in the trajectories of bodies that graze near its fire. For a comet whose orbital fate hinged on fractions of velocity, even Einstein's gentle curvatures mattered. Each perihelion passage demanded that general relativity's adjustments be folded into the orbit, lest the numbers drift toward error. Then there was solar radiation pressure, the faint push of light itself. For most objects, it is negligible, a feather touch against a mountain. But 3I Atlas was no mountain. It was a body shedding jets, flinging out clouds of dust, expanding its cross-section to photons. For its grains, solar pressure became significant, nudging trails of debris into orbits that diverged from the parent, spreading like ghostly echoes across space. Even the comet's core, fragile and porous, might have felt a whisper of that light, accelerating or decelerating imperceptibly but persistently. Disentangling these influences was an art as much as a calculation. Astronomers had to separate the push of sunlight from the thrust of jets, the curvature of space-time from the tug of planets, the fragmenting weakness of the nucleus from the inevitability of gravity. Each factor left its fingerprint, faint but distinct, in the residuals between prediction and observation. To read them was to see the comet as a palimpsest layers of physics inscribed upon a fragile stone. The challenge mirrored earlier debates around Oumuamua, whose unexplained acceleration had kindled theories of exotic physics or alien technology. In the case of 3I Atlas, the question was inverted. Had its slowing been entirely natural, or was there something more? Careful modelling suggested the jets and dust could account for much, perhaps all, of the anomaly. Yet the unease lingered, for each refinement seemed to leave behind whispers at the edges of certainty. In truth, the comet had become a proving ground for physics itself. It was not only an interstellar relic, but a test of our equations, how well we could measure, how carefully we could account for the dance of forces both classical and relativistic, gravitational and photonic, chemical and chaotic. Every adjustment was a reminder that the laws we so often consider universal are tested, not assumed. And so, in chasing its orbit, scientists were forced to confront not only the comet's mystery, but the very precision of their tools. 3I Atlas became a mirror for our understanding of the cosmos, showing us both the power of our theories and the humility demanded by their limits. To understand 3I Atlas was to glimpse beyond the narrow walls of our solar system into the turbulent birthplaces of stars themselves. For its existence raised a simple, profound question. How many such bodies wander the galaxy? And why do stars in their earliest years fling away fragments of their creation with such violence? The answer lay in the physics of planetary birth. When a star ignites, its surrounding disk of dust and gas begins to assemble worlds. But the process is chaotic, littered with collisions, migrations, and gravitational upheavals. Growing planets scatter debris like children tossing stones into a pond. Giant planets, in particular, act as slingshots, hurling icy remnants outward at escape velocity. Most vanish into the interstellar dark, exiles forever. Cosmologists often speak of cosmic inflation, the sudden ballooning of space-time in the universe's first breath. In a way, the scattering of comets by newborn planets is its miniature echo. The disks are like dandelions, fragile seeds cast into the wind of the galaxy. Most seeds will never take root, but some may drift for billions of years before brushing another system, another sun, another chance at belonging. 3I Atlas was such a seed, its voyage written not in decades but in epochs. To catch one of these dandelion seeds in orbit around our star was astonishing. It suggested that the Milky Way is not empty, but thick with wanderers. For every star that births planets, countless fragments are expelled. Multiply that across 400 billion stars, and the galaxy may swarm with comets adrift, unseen yet ubiquitous. The night sky, silent to our eyes, is in truth alive with ghosts of other nurseries. In this light, 3I Atlas was not an anomaly but a sample, a single grain plucked from an endless storm. Its capture was improbable for one object, yes, but inevitable for the galaxy as a whole. Given enough time, every star becomes both a source and a catcher of seeds. The Milky Way itself is a garden of fragments, stars exchanging material like pollinators, scattering chemistry across light years. This realization was humbling. It meant that our solar system is not an island, isolated and self-contained. It is a participant in a vast network of exchange, shaped not only by its own history, but by the histories of stars we will never know. To trace the orbit of 3I Atlas was to see the fingerprints of cosmic inflation mirrored on a smaller stage, the scattering of matter, the sowing of futures, the endless dispersal of beginnings. In the fragile ice of this captured wanderer lay the truth that creation is not local but universal. Stars do not hoard their relics. They cast them into the dark, trusting the galaxy to carry them. And sometimes, impossibly, one of those seeds takes root in the orbit of another sun, circling like a message written in ice. You are not alone. As the models converged and the evidence of capture grew harder to deny, the community began to wonder, could 3I Atlas be telling us something even stranger than cometary physics? In the faint deviations of its orbit, some saw echoes of earlier puzzles, whispers of the same uncertainties that had haunted Oumuamua. What if, they asked, the odd accelerations we traced were not simply byproducts of jets or dust, but clues to something deeper, forces not yet written into our textbooks? The most daring voices linked these whispers to one of the greatest enigmas in all of physics: dark energy. The universe itself accelerates in its expansion, pushed by an unseen agent whose nature defies comprehension. Could small bodies, drifting between stars, be sensitive to subtle interactions with the cosmic vacuum, manifesting as anomalous accelerations we mistake for outgassing? Could comets like 3I Atlas be test particles, their oddities hinting at the texture of space-time itself? Others reached for different frontiers: modified gravity theories, quantum field interactions, exotic particles, all were invoked as possibilities. A comet's fragile body became a canvas onto which humanity projected its deepest uncertainties. If we could not reconcile the slowing of 3I Atlas with the familiar forces, perhaps it was because a shadow of new physics lay at work, masquerading beneath the jets and dust. Of course, caution was louder than speculation. Most astronomers insisted the natural explanations sufficed. Jets and resonances, Jupiter's pull and fragile ices, these could account for everything without invoking the exotic. But even among the cautious, the unease remained, for the universe has a way of planting anomalies at the edges of certainty, nudging us toward questions we do not yet know how to answer. The phrase "dark visitors" began to circulate not in the sense of aliens, but of enigmas. Interstellar comets became metaphors for the unknown, emissaries from the broader cosmos that carried with them not only foreign chemistry, but the possibility of hidden physics. The very fact that they were rare, faint, and fleeting made them perfect messengers, difficult to study, impossible to control, yet irresistible in their implications. Could 3I Atlas be such a messenger? Perhaps not. Perhaps it is only ice and dust, playing out familiar processes in an unfamiliar context. Yet the timing, the rarity, the coincidence of anomalies could not help but invite speculation. And in the quiet of observatories, as light curves flickered on screens, some scientists allowed themselves to wonder if these strange bodies were the first probes not of civilizations, but of reality itself, nature's own experiments, testing the laws we thought unshakable. In the end, whether or not 3I Atlas revealed new physics, it accomplished something profound. It reminded humanity that even the smallest wanderer, captured by chance, could reopen the deepest mysteries of existence. In its faint glow was the question that drives all science. What if the universe is still stranger than we dare to believe? With every headline and speculative whisper, a darker fear began to surface, one tied not to dust or jets, but to the very fabric of the cosmos. In popular imagination, the capture of 3I Atlas became entangled with a terrifying idea: vacuum decay. The notion that the universe itself is precarious, that the vacuum we live in is not truly stable, but a false minimum, a metastable bubble, waiting only for a spark to collapse into a deeper state of being. The thought is unnerving. If a bubble of true vacuum ever formed, it would expand at the speed of light, rewriting the laws of physics in its wake. Molecules, atoms, even the constants of nature would vanish. Life, stars, matter itself, all undone in a silent, unstoppable front. And because it travels at light speed, there would be no warning, no defense. Existence would end before a thought could form. Inevitably, the arrival of an interstellar comet triggered the question in public forums. Could such an object, with its alien chemistry or exotic origins, trigger this apocalypse? Was 3I Atlas a messenger of doom, a seed of destruction planted in the sun's orbit? Scientists answered with sober clarity. The fear, though chilling, was misplaced. The energies required to destabilize the vacuum are incomprehensibly vast, far beyond the feeble heat of cometary jets or the gravity of a captured body. Even particle accelerators, smashing protons together at energies orders of magnitude higher, pose no threat of such a catastrophe. If the vacuum is metastable, it is cosmic processes colliding neutron stars, primordial inflation that would decide its fate, not the fall of an icy wanderer. Yet the fear persisted, because it carried a certain poetic resonance. The idea that an alien body might undo us tapped into something primal, the sense that the universe holds dangers we cannot control, forces so absolute that human effort is irrelevant. 3I Atlas became, in these imaginings, not merely a comet, but a symbol of our vulnerability in a universe indifferent to survival. Still, in the clarity of science, reassurance could be found. Vacuum decay remains a theoretical ghost, a possibility embedded in equations but unprovoked by anything we know. The comet, fragile and fractured, posed no such threat. If anything, its presence reminded us of the opposite, that life continues, improbably, against a backdrop of chaos. In reflecting on these fears, philosophers of science pointed to a deeper truth. The terror of vacuum decay is not really about comets or cosmic mechanics. It is about our unease with impermanence, our awareness that existence itself may be contingent. 3I Atlas did not threaten us with annihilation. It threatened us with the reminder that we live on borrowed time, within a universe whose long-term future remains uncertain. And perhaps that is why the fear lingered. For in the fragile glow of an alien wanderer, humanity saw not doom itself, but the shadow of a question too vast to ignore. How long can the fabric of reality hold? As theories multiplied around the alien captive, some voices turned toward an even broader speculation. Could such objects be emissaries not just from other stars, but from other universes? The word multiverse slipped into the conversation, as it so often does when the strange and unexplained press at the edges of our understanding. The idea is intoxicating. If there are other universes beyond our own, perhaps their debris might cross the thresholds between them. Perhaps 3I Atlas was not only interstellar, but intercosmic, a shard flung across the seams of realities. To a poetic mind, the thought was irresistible, a visitor not only from another star, but from another cosmos altogether. Yet science, steady and precise, drew the boundaries. No evidence pointed to such exotic origins. The chemistry of 3I Atlas, though foreign in detail, was not alien in kind. Its isotopes, its volatiles, its fragile dust, all were built from the same elements that fill our own periodic table, the same physics that governs our comets. There was no sign of impossible matter, no fingerprint of alien laws. More likely, the comet was exactly what its orbit suggested, a fragment from the Milky Way itself. Perhaps it was born around a small red dwarf, one of the galaxy's countless dim suns. Perhaps it had been scattered during planetary migration in a system not unlike our own. Ejected into the interstellar night, it had drifted for untold millennia until Jupiter's gravity and its own jets delivered it into our keeping. Its story was extraordinary, but it was still written in the ink of this universe. Still, the very act of asking the question was revealing. It showed how quickly the human mind leaps from observation to myth, from science to philosophy. The multiverse is a grand mirror for our longing to believe that reality is richer than what we can see. And though 3I Atlas offered no proof, it reminded us that the line between speculation and discovery is often drawn only after the fact. In the end, what mattered was not whether the comet came from another universe, but what its presence told us about our own. The Milky Way is vast enough, fertile enough, mysterious enough, without invoking realms beyond. Stars scatter their children into the void, planets fling their icy relics outward, and across billions of years, those relics drift, collide, and sometimes are captured. The multiverse is a haunting idea, but the galaxy alone is wondrous beyond measure. Thus, 3I Atlas became not a messenger from other universes, but a reminder of the richness of this one. Its orbit, its chemistry, its fragile glow all testified that even within a single galaxy, the diversity of worlds and histories is endless. We do not need the multiverse to find the extraordinary. It is already here, circling our sun, a fragment of another dawn caught in the gravity of ours. The strangeness of 3I Atlas eventually gave rise to a humbling realization. Perhaps this event was not unique at all, for if the solar system had managed to capture one interstellar wanderer, why not others? Perhaps the improbable is not impossible but routine, its frequency hidden from us by the limits of our vision. Simulations began to explore the idea. Astronomers ran models of planetary systems forming and scattering their icy relics, hurling billions of fragments outward into the galactic sea. They then modeled stars like ours, surrounded by giant planets, sweeping through those seas over billions of years. The result was startling. Capture was not only possible, but inevitable. Given enough time, every planetary system should snag a few interstellar strays. Some would linger for centuries, others for millions of years before being perturbed again and flung back into the void. If so, then 3I Atlas was not an anomaly, but a revelation of a truth long concealed. The solar system may already host dozens, even hundreds, of captured interstellar bodies. They would masquerade as ordinary comets, indistinguishable until their chemistry betrayed them. The Oort cloud itself might be salted with such exiles, mixed seamlessly with our own, an archive of alien nurseries hidden in the icy dark. This possibility redefined our view of the solar system. It was no longer a closed system, a sealed archive of the sun's history alone. It was porous, leaky, part of a galactic ecosystem where stars constantly exchanged material. Our comets might not all be ours. Our skies might carry the fingerprints of worlds we will never see. For planetary science, the implications were profound. Every comet that blazes in the sky could, in principle, be a messenger from another star. Every meteor shower might contain a few grains, not of our sun's family, but of another's. The boundary between native and foreign blurred into irrelevance. In this light, 3I Atlas was not a miracle, but a mirror. It showed us that the galaxy is not a void separating isolated stars, but a sea in which material constantly drifts, trades, and mingles. Capture, rare in any given year, becomes certain across cosmic time. The extraordinary became ordinary. And yet, in that ordinariness lay something greater. The recognition that we live not in solitude but in exchange, our solar system one thread in the broader fabric of galactic life. 3I Atlas was not alone, and neither are we. As the debates swirled and the simulations grew more precise, the comet itself began to take on a symbolic weight beyond science. Humanity, after all, has always seen itself reflected in the skies. Stars became gods, planets became omens, comets became harbingers of change. 3I Atlas was no different. Its capture, its refusal to depart, became a mirror for our own condition. For here was a body born under another sun, cast adrift by forces beyond its control, and now caught in a rhythm it never chose. It circled a foreign star, not by will, but by circumstance, a captive of chance alignments, of resonances, of fragility. In it, philosophers and poets saw the echo of cultures and civilizations, of human beings themselves. How often are we, too, thrown from our origins by forces vast and impersonal? How often do we find ourselves bound to orbits not of our choosing, reshaped by histories we cannot escape? The metaphor grew heavier the longer one looked. Civilizations rise with momentum, fueled by their own histories, only to be deflected by contact with others, captured by tides of culture, politics, and chance. Like comets, they shed fragments of themselves as they move traditions, languages, ideas, some lost, others preserved as trails for those who follow. Weakness, fragility, displacement, these are not merely conditions of comets, but of humanity. Yet there was resilience too. Just as 3I Atlas, fragile and fractured, survived its exile to become something extraordinary, so too do cultures adapt, endure, and transform when forced into alien orbits. The comet became a symbol not only of displacement, but of survival through displacement, of finding permanence, even when permanence was never intended. In this way, science and philosophy braided together. Astronomers measured isotopes, philosophers saw allegory, spectra spoke of alien chemistry, poets heard stories of exile and belonging. The comet existed in both realms at once, a physical object circling the sun and a mirror in which humanity could see itself reflected. And perhaps that was its greatest gift, not the data it carried, not the equations it tested, but the reminder that we too are wanderers, born of stardust, shaped by forces we cannot control, captured by a planet and a history we did not choose. We orbit together, fragile yet enduring, bound not by choice but by circumstance, and in that binding we create meaning. 3I Atlas, in its silent arc, told us a story about ourselves, a story of exile, capture, fragility, and the strange beauty of survival. From the first faint smudge on Atlas's detectors, 3I Atlas had been a source of awe, speculation, and unease. Yet, as its orbit settled and its chemistry was unraveled, one question pressed harder than all the rest. Should humanity try to touch it? The thought was irresistible, to send a spacecraft not merely to fly past, but to reach into the plume of its coma, to capture a fragment of its dust, to bring back to Earth the frozen record of another star system that would be a triumph beyond any previous mission. No rover on Mars, no probe to Saturn's moons, no telescope staring into the cosmic dawn could rival the intimacy of holding in our laboratories matter that had once orbited an alien Sunday. Mission proposals began to take shape in the minds of engineers. A kinetic fly-through, scattering dust collectors into its tail, a rendezvous craft, shadowing the comet for months, as Rosetta once did with 67P. More daring still, a sample, return capsule, carrying grains back to Earth, as OSIRIS-REx had done with Bennu. But this was not just any asteroid or comet, it was interstellar, fragile, unrepeatable. The stakes were immeasurable. Yet with possibility came danger. Every mission risked altering the very thing it sought to preserve. A lander might destabilize a surface already fracturing. A harpoon or drill could trigger jets that shredded the craft. Even the act of touching could contaminate, mingling Earth's chemistry with the aliens and forever erasing the purity of its story. Scientists debated fiercely. Some argued that the opportunity was too rare to ignore, that if we did not seize it, centuries might pass before another interstellar capture presented itself. Others urged restraint, insisting that observation alone preserved the mystery intact. that reverence sometimes meant distance. The argument was not only scientific, but philosophical. Do we have the right to touch what is not ours? Do we risk destroying the very wonder we wish to know? In the silence of these questions, 3I Atlas became more than an object of study. It became an ethical mirror, forcing humanity to confront the tension between curiosity and reverence, knowledge and restraint. Still, the dream of contact lingered. Engineers sketched trajectories, scientists drafted instruments, agencies weighed costs. The comet, silent and indifferent, drifted on, carrying within its fragile body the possibility of the greatest scientific harvest humanity had ever dared to attempt. What we dare to touch, we risk to lose. Yet what we do not touch may slip away into time, leaving us forever to wonder. And so 3I Atlas posed a question not only of science, but of courage. Are we willing to reach for a piece of another sun, knowing it might crumble in our grasp? In the end, the mathematics of its orbit spoke with finality. 3I Atlas was not leaving. Unlike Oumuamua, which vanished into the abyss, or Borisov, which flared and fled, this visitor had joined the sun's family. For centuries, perhaps for millennia, it would remain a foreign fragment permanently woven into the fabric of our skies. What does it mean when something alien decides to stay? The question is larger than astronomy, for the comet is not simply ice and dust. It is the embodiment of chance, of fragility, of the porousness of cosmic borders. It is proof that the solar system is not a sealed archive of its own past, but a living participant in the galaxy's endless exchange. 3I Atlas is not ours, yet it is here, circling the same star that warms Earth. It is a reminder that we share our home with relics of other beginnings. For science, its permanence is both a gift and a challenge. A gift because it offers time to measure, to plan missions, to peer into its chemistry with the patience of decades. A challenge because time breeds change. Resonances will shift, jets will fracture, debris will scatter. The longer it stays, the more it will shape the solar system not only in models and equations, but in real dust, real fragments, real risks. For philosophy, its permanence is a mirror. The comet is exile turned resident, alien turned neighbor. It is fragility transformed into endurance. And in its orbit, we see ourselves, a species bound to a world by gravity, lingering in a universe that never meant to keep us. We too are wanderers who have stayed. The presence of 3 Atlas does not answer the great questions. It does not reveal why the universe expands, or whether life is common, or how long existence itself will last, but it reframes them. It shows us that the galaxy is not distant, not untouchable. Its relics fall into our hands. Its seeds orbit our Sunday. Its stories are written into the light we gather, the dust we breathe, the comets we watch burn across our sky. If the alien stays, then so too does the mystery. And perhaps that is the greatest gift of all. Not closure, but continuation. Not an answer, but an enduring question, circling the sun in silence, waiting for us to decide how to live with what it means. And now the story slows, as the comet itself drifts outward, its brilliance fading into the cold dark. The telescopes fall silent, their shutters closed, the data archived. Yet above us, invisible to the eye, 3I Atlas continues its orbit, carrying the silence of another sun, circling endlessly beneath the same constellations that have watched humanity's rise. It will return, long after we are gone. When languages shift, when empires crumble, when the memory of these years is dust, the comet will still be there, bound to the sun, keeping its rhythm. Perhaps other civilizations will look up and name it anew. Perhaps none will remain to see. but the orbit will go on, indifferent to witness. There is a comfort in this, a reminder that the universe endures beyond us, that beauty is not diminished by our absence. The comet does not need us to measure it, to argue over its isotopes, to debate its risks. It simply is. And in its being, it whispers a truth we too often forget, that permanence and impermanence are entwined, that to stay is no less miraculous than to go. So let us leave it there, drifting in its arc, a fragment of another dawn circling beneath our star, a visitor turned neighbor, a story that refuses to end. And as we close our eyes tonight, we may carry with us the thought that somewhere above, in silence, 3I Atlas keeps watch, not as a harbinger, not as a threat, but as a reminder that the galaxy itself lives among us, and that even the most alien can, against all odds, find a place to stay. Sweet dreams.